Hello fans and cooking fanatics. Welcome to Cooking with Anthony Bourdain's less famous brother, Phil Bordain. Today we'll be cooking a dish I like to call Math Unit 7. Let's go to Chef Joel with the ingredients.
Okay, so to make Math Unit 7, we need to get 10 ingredients. Let's get straight to them. Number 1 is the power function, number 2, the end behavior, and number 3, the degrees. The power functions come in the form of y equals k times x to the power of p, and are commonly used when dealing with areas and volume. Proportions in power functions are when y equals k times x. Here, y is directly proportional to x. As x gets larger, y also must get larger. Inverse proportions are when y equals k over x. Here, y is inversely proportional to x, and as x gets larger, y must get smaller. Please graph the following function of f of x equals x cubed minus 3x squared plus 1. Your graph should look like this. Next, the degrees. The degrees of a polynomial is the highest degree of its terms. The degree helps us predict the end behavior of a function. The end behavior. The end behavior of a polynomial function is the behavior of the graph, negative or positive infinity. To predict the end behavior of a polynomial function, first check whether the function is odd degree or even degree, and whether the leading coefficient is positive or negative. Please graph the following function of f of x equals x cubed minus 3x squared plus 1. Your answer should be, as x approaches infinity, y approaches negative infinity, and as x approaches infinity, y approaches infinity. Let's go to Chef Phil.
Hi, I'm Chef Phil. And today, we're going to talk about absolute value. Absolute value has the generic shape of the letter V. Let's talk about why this happens. As the domain goes to negative infinity and positive infinity, the range will always be positive, because the absolute value is how far the number is away from 0. Let's use this example. The absolute value of 2x minus 2. This is the amount of tomatoes we're going to use. This is a binomial because it's two terms separated by subtraction sign. Pause the video to solve the problem. 2 times 3 is 6, and the absolute value of 6 is 6. 6 minus 2 is 4. We're going to use 4 tomatoes. Now, if the number outside the absolute value is negative, then the range will become negative 2. Let's use the other example. Pause the video so you can do this on your own. The absolute value of negative 3 is 3. 3 times negative 3 is negative 9. Plus 2 equals negative 7. Now, we cannot use negative 7 onions, so we're going to use 7 onions. Now, let's go to Chef Abraham.
Thank you, Chef Jonathan. We have 4 more ingredients to cover, so I'll go straight into it. This is an example of a cube root function. Notice how it starts slowly at first, then speeds up eventually in the middle, and at the end is slow again. That is the shape of a cube root function. Cube root functions are when the x of the cube root equation is cube rooted. Another ingredient we can take from this is increasing. Increasing is exactly what it sounds like. It is when graph values are going up. What can you do to the parent function to shift it up 2 units? The answer is add 2 to the outside of the equation. The second question, is this graph increasing? The answer is yes. The next ingredient we're going over is the square root function. The square root function is growing fast at first, then slows down. In this function, the x is square rooted. The last ingredient we need is decreasing. Decreasing is when a graph's values get lower and lower. Let's practice this. How can we shift this graph 3 spaces left? The answer is add 3 to x. Is this graph decreasing? The answer is no. So that's how you make Math Unit 7.